we learn uh, different parts of the data like frequency number, and all that stuff we learned from here. Now we have to learn the different ways in which we can represent our data. Like for the data, we learn how to find the mean, mode, median, quartiles, interquartile range of the data. All these things we learn in our uh, previous unit. That was all about the data. Now we will learn in this one how we can display our data. Okay, even this picture is helping you. This is a display of different objects, fruits, vegetable. So in the same way, if you have the data, so how we can display the data? One of the way to display the data is histogram. Okay, now about the histogram, let me about histogram. It is a graphical way of representation of the data that we use to represent. Most of the time students confuse between histogram and a bar graph. Keep in mind, let's say, for example, if you look at this one, this is a histogram, okay? And here maybe, no, this is also a histogram. In histogram, the size of the bar can be different. There will be no gap between the bars. But in bar graph, the size of each bar, like the width of each bar, I use the wrong term, sorry for that. The width of each bar will be same. Height can be different in that also. But in bar graph, the width will be same and there will be gap between those. And it will be equal gaps. But in histogram, there will be no gap and the width of the bars can be different. Okay. Now we have here for this one few terms. Like let's suppose if you have a histogram, let me say, I'm going to show you. Let's suppose if I have a histogram, quickly just a rough histogram I'm going to show here. Let's suppose this is a histogram. This is a histogram. If you look at the histogram, the bars of the histogram will have a height, yes, and will have the width also. Now, if you have any data with any given data, the height of the bar of the histogram, that is, we will use word for that, frequency density. Of course, in your IGCSE, you also took that one, but now we will move to advanced level, histogram and frequency density. Then if this is frequency density will represent the height. For example, the height of on this side, it means we will take a frequency density. And the width of the bar, this width of the bar, that is represented by the class width. About the class width, in the previous unit, we already discussed in detail. Okay. Now, how we have to, one formula you have to remember, frequency density is always equal to frequency over class width. And even from that, for frequency density, I will use FD, that is equal to frequency over class width. So we can derive the formula of the frequency. Frequency will be equal to frequency density multiplied by class width. That can be, okay. And in the same way, sometime you may need the class width. So class width can be frequency over frequency density. So these formulae you have to remember. Okay, now let's say I will move to exercise to do certain questions and then we will discuss it. First of all, if this is a histogram, let me copy this question. Oh, sorry, this is an example now. Let me move to exercise directly. Yes, here I have Question is, the data in the table shows the mass in kilograms of 50 adults of a fish. Draw a histogram of the data. If you look at the histogram, I told you in histogram you need frequency densities and class width. Right now, this is the given data. For data, whenever you will look at any data, what is the first thing that you have to take care about? That is about the gap. In this data, there is no gap. So that is good thing. Your work, your effort, you have to do less effort for that one. The second thing now that you need for is you need frequency densities and class width. Then you will be able to draw the histogram. So first of all, I will add two more columns for this one. I will add the columns for this one. One of the column will be that I can add here is for the class width of each data, and the other column will be for the frequency density. Okay, first let's take the class width for each group. How do we take the class width? This is the upper class boundary, this is lower class boundary. So upper class boundary minus lower class boundary, that is the class width. It means class width for this one is 5. For this one is also 5. Now class width for this one is also 5. Class width for this one is 5. And class width for this one is also 5. It means in this case, the width of each bar will be same because the class width for each class is same. The size of each class is same, 5. Now we will find the frequency density for each class. Now this is the formula for the frequency density. Frequency density is equal to frequency over class width. Now frequency density is frequency. Frequency for this class is 4, class width is 5. So it will be 4 over 5. That is 0.8. Meanwhile, can you complete the frequency density for this one? Just give me 1 minute, please. Complete frequency density for each class because you are having the frequency and you have the class width as well. So complete that. I'll just be back in 1 minute. Yes, now any one of you can please let me know. Ayub, you're right, but unfortunately I have to move each time to chat box. If you can say, anyone can open. 2.4 is for this one. Okay, for the next one.
4.6.
2.6. Okay, for this one, 1 point something.
No,
Will
4.6.
4.6?
Yeah.
Oh, okay, sorry. 4.6. Okay. What is for this one? 1 point? 1.6?
1.6 and 0.6.
Yes, and 0.6. Okay, all right. So this is our frequency density now. Now is the time and to draw the histogram. Let's draw the histogram. Now to draw the histogram,
Sir,
yes,
what is a frequency polygon?
I will come to that also, don't worry. That is very easy to draw. To draw the frequency polygon, we need to draw first our histogram always. Okay. Now, right now, to draw this one, obviously we need some scales. Look at the highest cumulative frequency, frequency density. The highest frequency density is 4.6. So it means if on that side, oh my God, let me redraw that one. I can make it even more better. If I will start, so from here till here, okay. Let's say here if I will say is 0, on this side I'm taking a frequency density, and obviously on this side will be the class width. Okay, now what we have to do, I can say this is 0. The highest frequency density is 4.6. So I can make a gap of 1, 1. This is 1, this is 2, 3, 4, and 5. Okay, now class width. For class width, for each one is 5, 5. If you look at, but what are our classes? Our classes are from 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. So you can do in this way. This is 0. You can make a gap of 5, 5. This is 5. Then next 10. Then 15. Then is 20, 25, 30, 35. I try to keep the gap same, but maybe I'm not using any scale, so just excuse my difference if there is. Now, for the first class, we know it is from 10 to 15. The frequency density is 0.8. So it will be like this, from 10 to 15, 0.8. 0.8 will be less than 10, less than 1, so almost here. So you will make a bar whose width will be like this one and height will go till this. This is your first bar. Okay. Then the second bar is 2.4. Frequency density is 2.4 and it's from 15 to 20. Okay, from 15 to 20. It is from 15 to 20 and 2.4. 2.4? Yes. So if this is 2, so 2.4 will be almost, you can say, increase this one from 15. If this is 2, so 2.4 almost can be here. If you will use a graph paper, then easily you will be able to make that difference. And till 20, this is 20. So that bar you will make. Okay. Then next, from 20 to 25 is 4.6. Okay, from 20 to 25 is 4.6. This is 4, so 4.6 almost here. So this bar you can make. Okay, this is from 20 to 25. Then is 25 to 30 is 1.6. Okay, 25 to 30 is 1.6. 1.6. Okay, let's say you can say this one. And 30 to 35 is 0.6. 0.6 will be most probably here. So this is your histogram. Okay. Once you draw your histogram, the next part is saying on the same set of axes, draw a frequency polygon. Now for frequency polygon, to make the frequency polygon, what you have to do is you will start from the mids. Okay. You will join for making the frequency polygon. You will join the mids of its mid. You will join with its mid. Okay. Like mid of this one, you will join this one. Okay. After that, its mid you have to join with its mid. Mids you will join this one. Then its mid with its mids. Then its mid with the next bar mids. Oh, sorry. You can say it's making a polygon. This polygon we say is a frequency polygon. Okay. So that is pretty simple to draw a frequency polygon from a histogram. Clear?
Yes, sir.
Okay. Now the second question. Question is, some students took part in an obstacle race. The time for each student to complete the race was noted. The results are shown in the histogram. Give a reason to justify the use of histogram to represent this data. Uh, Basically, the reason is whenever for the time, because we are taking the time, continuous and discontinuous data we did not took. Time being a continuous data is always justifiable when we use it for any distance oriented activity. As this is a race, so in race speed matters. That is a distance oriented activity, so that is why time is justifiable. Even for a while, leave part A. Okay, no need. Uh, Move to part B. 90 students took between 60 and 70 to complete the race. Okay, this is 60 and 70, between 60 and 70. The total number of students are 90. Find the number of students who took between 40 and 60. So we have to determine the number of students between 40 and 60. First, you have to count the number of boxes. Let me increase the size a little bit. Count the total number of boxes between 60 and 70. How you can count the number of boxes? Quite easily determine the height. If you go on that side, so how many boxes are there? One, two, let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I count it accurately? Once again, because I don't want the mistake. Anyone with that focus? Let me increase the size even a little bit more, then we can zoom back. Now it is pretty easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then horizontally, how many are? You can say 1, 2, 3, 4, 5. So 15 by 5. Total, how many boxes will be? 15 by 5. 75. It means these 75 boxes actually, if I can say that the total number of the boxes are 75, because it's representing between, again, can you please make sure that we counted the number of boxes correct? 90 students took between 60 and 70. Okay, so total number of boxes are 15 by 5 or 75. So 75 boxes are representing, in other words, how many students? 90 students, because between them there are 90 students. So they are representing 90 students, because frequency. What is on that side? On that side is frequency density. Yes, on that side is class width, and frequency density multiply class width is always equal to frequency. That represents the number of students. So that is why we counted the number of boxes. So 75 boxes represent 90 students. Yes. So what about one box? If we will take one box, will represent 90 over 75 students. Yes. Okay. So we have to find the number of students who took between 40 and 60 seconds. So between 40 and 60, now you have to, we know already that one box is for 90 over 75. Now count the number of boxes for this one. How many number of boxes are in this part? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this is 12 and a half. I mean 12.5 is boxes are on that side. Make a, okay. Then on that side, how many boxes are? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 into 12.5. The total number of boxes on that side are how many? 125. So these are 100. It means if one box is representing these number of students, so 125 boxes will be equal to how many students? Will be 90 over 75 multiplied by 125. Calculate that. 90 divided by 75 multiply with 125. So it represents 150 students. In this way, we can calculate the number of students. Okay. Now, next, it has been asked that find the number of students who took 80 seconds or less. Now, it means you have to count actually the number of boxes in this one. In this one, already we know how many boxes were here, 75, and here we had the number of boxes 125. Yes, 125 boxes were here. Now count the number of boxes here also. Just count the number of boxes here also, because question is saying find the number of students who took 80 seconds or less. So we know number of boxes here, number of boxes here. Calculate the number of boxes here as well. So how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then 16, 17, 18, 19, 20, 21, and this is half box, 21.5. Okay, 21.5. And horizontally, how many are? 1, 2, 3, 4, 5. Multiply with 5. So 21.5 multiply with 5. These are 107.5 boxes. So we are having 107.5 boxes. So as we know that 175.5 boxes. So now will be how many total students actually? First, find the total number of boxes between that. These boxes are 125 plus 75 plus 175.5. So the number of boxes are 375.5. Yes,
Why 175.5?
because look, vertically how many boxes were? 21.5. Horizontally how many were? 5. So 21.5 with 5 is 107.5. Oh, sorry, 107. You saved us on time. It is 107, not 175. So 107.5. So now how many total number of boxes will be? Let's recalculate that. 125 plus 75 plus 107.5. So total number of boxes are 307. So it means for part C, I can say 307 boxes will be equal to 90 over 75, because we know for one box, these are the number of students. So for 307.5, so multiply by 307.5, what it will give us? Okay, multiply it with 90 over 75. So 369 students. So it means this part till this one. Now part D is saying calculate the number of students who took part in the race. It means now you have to calculate total number of students. Sorry. So you have to calculate number of boxes for this one, and for this one, and multiply them with that number. I think this part you will be, and then when you will have the total number of boxes, multiply them with that. So you will be able to calculate. Understood or not? Please confirm. You will be able to calculate the number of boxes in this bar. Yes. Calculate the number of boxes in this bar. Calculate the number of boxes in this bar. Add all the boxes and then multiply them with 90 over 75. You will get the total number of students. Okay. Clear?
Yes, sir.
Hmm. Number three is same. Why is the histogram suitable to draw suitable diagram to represent these data? Right now, leave the reason why histogram is useful. Why we prefer histogram other than other data. So leave it for a while here. Part B is how many people entered the competition. It is same. When you have to, when you are taking actually the number of people, so it means you have to find the frequency for each. So use the same method that we followed here. Look at this one. What is part B? How many people entered the competition? Okay, so you have to, this is frequency density. Yes, this is class width. Actually, distance is representing the class width. First, find the number of boxes here. Calculate the number of boxes here. Calculate the number of boxes here. Calculate the number of boxes here. And calculate, oh, instead of that one, I can have, as we are finding the frequency. So why not to uh, take it in that sense? This is class width. It can be even more easier. You can make it even more easier than that. Instead of that one, what you can do, because number of people mean frequency. Yes. For this, what is the class width for this one? Is 20. Yes. What is the frequency density for this one? 2. So it means the number of people in this will be 2 into 20. Yes. Okay. What is the class width for this one? Class width of this one is, this is 30. One second. How many boxes? 1, 2, 3, 4, 5, 6, 7. Each box is representing a 2. You can see. So for this one, it is 14. Yes. Multiply. What is the height for this one? If this is 4, how many boxes are representing 1, 2, 3, 4, 5? 5 boxes are representing 2. Yes, 5 box equal to 2. So what will be one box? That is 2 over 5. So how many boxes now we are having here? If this is 4, this is 4, then mm, each box 2 over 5 is 0 0.4. Okay. This is 4, 4.4, 4.8, and then half. So total 5. It means 5. So multiply by 5. This height is still 5. Okay. Now for this one, this is from how many? Oh my God, even these boxes I calculated wrong. These are 14 and half. Yes. So if this was 2, 4, 6, 8, 10, 12, 14, and this half will make it 15. So 15 by 5. Okay. This is half box. The next one. Take care about that. Now from here, this, because each box is representing 2. This one is 1, then 3, 5, 7, 9, and this one make 10. Okay, 10. Class width is 10 for this one. So it is 10 by, okay, now what is this one? Till this one is easily, it's given already 10, 10 by 10. Now for this one, this half box 1, 3, 5, 7, 9, 11, 13, and 15. So 15 by, what is this height? 6. Now for this box, we are having 2, 4, and this half 5. So this is 5 by, what is this one? On that side, we know already each box is 0 0.4. So 0 0.4, 0 0.8, and 1. So this is 1, 5 by 1. So it means if you want to find the total number of people, that will be this one. For part B, total number of people will be this 2 into 20 plus 15 into 5 plus 10 into 6 plus 15 into 6 plus 5 into 1. So you just have to calculate that simply. Okay. And then part C is saying estimate how many people threw between 30 and 40. Okay, this time you have to count the number of boxes. If you permit me to erase this work here, because right now it is between 30 and 40. Okay, so what you should do, make from 30 this one, all right, and then you have for 40. This is the line for the 40. So what you should do, calculate, because you have to estimate how many people threw between 30 and 40-meter distance. So in that case, you have to find the area first. First of all, what is area for this one? Number of boxes you can, each box is 2, so 2, 4, 5. So this is 5 by, what is this one? We already found that was 5, yes, 5 by 5. Okay, 5 by 5 here. And for this one, 1, 3, and 5. This is 5. Multiply with this height is 10. So it means the total number of people for this one will be for part C. Because frequency, then this is frequency density, this is class width, yes. So you have to follow that one. It will be 5 by 5 plus 5 by 10. So calculate, that will give you the frequency number of people for this one. Understood? Hmm?
Yes, sir.
Okay. Now for part D, how many people threw between 45 and 65? In the same way, this is 45 and this is 65. Yes. So what you should do, calculate the number of boxes, sorry, frequency for this one, frequency for this one, and add them. That will give you. So you can try part D, please. And estimate how many people threw less than 25 meter. Okay, 25 meter is here. This is 20, 24, 25 will be here. You can start from the half of that. Let me know you calculate the frequency for this one and frequency for this part. Just add them, that will give you. Okay. So if you will learn this reading of the data here, then inshallah further, no, you will try question number 4. Similar, there will be no problem. 5 also you have to complete the missing one. But the partially not entirely completed histogram shows in the time minutes procedure. Copy and complete the table. From 0 to 20, the frequency is 4. Can we do it next time? In our next class, the complete concept of frequency density and its outliers we will complete, inshallah. Next class, inshallah, will be on Monday, P2.
Okay, sir.
Okay.
Okay, sir.
Inshallah, see you on Monday. And I shared some